Well, good afternoon. This is Neuroscience 3 course. I'm Mariandro. So I apologize for the music, but I need to put some music to avoid the external noise. It's what we call white noise. So, having said that, we will start with this chapter today. We have to learn about attention and consciousness, and basically the brain areas related to attention and consciousness. And so I'm going to do this in three short videos to make them easy to upload to internet. And what I want you to do is to read the chapters, because I'm not going to explain the whole chapters. What I'm going to do is explain the images, the figures that you can see there, so then it's much easier for you to understand. So you need to read the chapters because you won't see any letters in here. It's only images, right? So we will start with the first image that you can see in the text. You can see two images, the figure A and figure B. Figure A is depicting what the authors call the default mode network. They use a specific technique which is called the positron emission tomography, which make it possible to see how the brain, in this case, it's consuming glucose. You know, it's one of the main food, let's say, for the brain. Yeah, glucose. So the hypothesis behind this is that the brain areas that are more active at a specific time consume more glucose, so you can see them more active. And what they found in these experiments were that people usually, when they are in a resting state, they're doing nothing, or they believe they're doing nothing, we believe we're doing nothing. Actually, the brain is very active, so you can see specific brain areas that are active even though we're doing nothing specifically. And they call this the default mode. They actually define the areas that they usually see on in the text, and they mention the medial prefrontal cortex, posterior cingulate cortex, posterior parietal cortex, hippocampus, and lateral temporal cortex. And they call all these areas the default mode network. In this image, the image A, you can see the brain inflated as a balloon. They can do this with this technique, so they eliminate all the sulci and the gyri, and you can see the brain areas specifically activated when a person is supposedly doing nothing, but the brain is still active. And the second one, the second image, image B, showing fluctuations from another technique called the fMRI. It's a magnetic resonance imaging, but functional, and you can see in the y-axis what they call a percentage of bold change. Bold means blood oxygen level dependent, and in the x-axis you can see the time in seconds. And what they're showing here is how the brain consumes oxygen, some brain areas of the brain. In this image specifically, they are showing two brain images, which are two brain areas, which are the prefrontal cortex and the cingulate cortex. I recommend you to look at these areas and on internet to see where they are located in the brain. And basically this image is showing that both areas, even though they are different brain areas, they are depicting the same fluctuations in this bold information. Then we have this figure 21.2, and they show again this activation of the default mode, because they have some hypotheses. You have to read on the text what those hypotheses are. But basically in here they're using again the functional magnetic resonance imaging technique to compare some experiments in where the subjects are required to remember past events versus a controlled task, or imagine future events versus a controlled task again. Yeah, so the important result is that even though you are remembering past events or you are imagining future events, the brain areas activated are very similar in both cases, always against a controlled task. Then we have a box about attention deficit hyperactivity disorder, which talk about this. It's a very well-known disorder, and what it is important here is just to understand that there are some hypotheses related to the brain areas associated to this disorder, and also some hypotheses which associate some neurotransmitters deficit related to this disorder. And after this is a very simple image, just trying to make an example of what is one kind of attention called bottom-up guide attention, where the salience of the stimulus is so strong that we cannot avoid looking at it. And this is in contrast with what we call top-down attention, where we decide where we're gonna pay attention, and consciously and voluntarily we pay attention to a specific stimulus, for example my voice in this video, and avoid some other stimulus that appears on the environment, like sounds, strong sounds, or lights. And this image is the first one I believe in this text that it's important to explain, because it's an experiment and they are just trying to make an example of what are the advantages of paying attention to some stimulus. And what they do here is they show to the participants one fixation point at the center of the screen, and they have to pay attention at it, and then they guide the attention by showing an arrow that it could be pointed to the left or to the right of the screen. And they, in the second image, the image at the right, you can see the attention, like they paint in a yellow color where the attention it is now. So now you're keeping on looking at the fixation center of the screen, but your attention moved from the center to the right part of the monitor because of that arrow that appeared at the very beginning. And then after that, one stimulus would appear either at the left or right part of the screen, and here you can see the effects of directed attention at the beginning of the task. So when your attention is directed to the same place where the stimulus is going to happen, this will have some effects on your detection and the reaction times, and when it appears on the other part, it will have different outcomes. And you can see those in the next figures. So figure 21.5 shows that subjects are more able to detect the cue when the cue appears at the same place where the direction was directed to. For example, when you direct attention to the left and stimulus appear in the left, you can detect it easily as compared to neutral or invalid when the attention is directed to the left and the stimulus appeared in the right. You are unable to detect. You may think, how can I can look at one place and then look at the other and I will detect it always. But the thing is, the stimulus, it's a flash, it's very fast, so it's not so easy to detect it. So if you do not direct your attention in advance, it's going to be really hard to detect it later. So one effect is this detection, and the other one is the reaction times, meaning you can detect it faster if your attention is directed to the same place where the stimulus is going to appear, yes, as the other option. And then we have this last image, which is kind of difficult to understand maybe, so also I'm going to explain this one. So in this experiment they have one image on the screen similar to the one appears above the letter A, and there are many places to where the subject can pay attention, and these lines, yellow and green, orange and blue lines, they changes every 2 seconds. They are changing the orientation and colors every 2 seconds, all of them. And the experimenter asks subjects to pay attention to one of these specific points in this image. So they have to pay attention to maybe very close to the center or going away from the center. So when they pay attention to the center, you can see that the activation, and this is showing this image on the left and on the right, is showing the brain. You can see that the activation is more focused on the occipital lobe, and as the attention moves to the outside of the image, then also the brain activation goes from the occipital lobe to the temporal lobe. So you can see this is the previous image. You can see the activation is in the occipital lobe, and then as you move away from the center in the image, also the activation in the brain is going from the occipital lobe to the temporal lobe. And this will be the end of the first part of this videos. We will continue in the second one.